Alright, what's up guys? In this video we're going to pick up some more calculus here. This is going to be another integration practice video. So to show you guys how to evaluate the integral 3x over x squared plus 2x minus 8 dx. Okay, so the first thing you want to do for something like this is just factor out the constant 3. So I'm going to pull that out in front of the integral sign before I do anything. Okay. Now what you can do for an integral like this is just take the partial fraction. So remember, for partial fractions, you need to be dealing with a proper fraction. So a proper fraction, hopefully you remember from algebra, if I have p of x over q of x, then the degree of p of x needs to be less than that of q of x, so we can't use partial fractions. So it's very important to remember when you're talking about using the integration technique, partial fractions. Okay, sometimes polynomial long division can be used to reduce the degree of the numerator in some cases, but it doesn't happen like that all the time. And another reason why I pulled the 3 out is because I did want to show you that partial fractions will work here, because notice here that the highest degree in the denominator here happens to be squared. You can imagine that this x is raised to the first power. So we can use partial fractions on this. Now let's go ahead and factor our denominator. So we're going to factor x squared plus 2x minus 8, and hopefully you remember from algebra 2 that we can just use the AC method. So we want two numbers that multiply to give me -8 but add to give me 2. And so if we factor this, this would just end up factoring to x minus 2 times x plus 4, and you can always FOIL this to determine whether or not you factored it correctly. Okay, so now that we factored it correctly, we'll have x over x minus 2 times x plus 4, and that's going to be equal to a over x minus 2 plus b over x plus 4. Okay, the next step is to add this side together, but what we need to do that is to multiply both sides by x minus 2 times x plus 4. So just to show you kind of how that works, I'll write everything out so you can see it. So that's what we have. And on this side, just to show you again how it's done, I'll use parentheses. So you can imagine that we're distributing. Okay, so as you can see here, these cancel, distribute in here. This would be a times x plus 4, so the x minus 2 is a cancel. This would be x plus 4 will cancel here, and we still have to multiply by x minus 2. So here's what you'll have after everything's done. You'll have x is equal to a multiplied by x plus 4 plus b multiplied by x minus 2. And that's what you should have after you have went ahead and multiplied both sides by these two binomials. Okay, so the next step, brighten the camera up a little bit. So the next step here is to determine the values of a and b. Remember, there's two ways you can do this. You can pick some values of x to substitute in to cause one of the, or you need to cause both of the variables to drop out because we have to solve for one of them. So pick which one you're going to solve for first. So just pick an appropriate x value, or you could equate coefficients and solve the system. You know, just picking some values of x will work just fine here that we can plug in to find the unknown constants. That doesn't work all the time. So first I'm going to do is just turn this around a little bit so that you can see this a little clearer when we actually go and start plugging some values in. Notice it's the same thing as that. I just kind of turned it around a little bit. Okay, so notice that if I let x, let's say I want to solve for a, okay? Let's say I let x equal 2. Then what happens is, when I substitute in, I'll get 2 minus 2, which is 0. B times 0 is 0, so that'll cause b to drop out. I would have to substitute in a 2 everywhere. So I have 2 plus 4, which is 6. So this would be 6a is equal to positive 2. If I substitute in the 2 for every spot I see in x. Dividing both sides by 6 to find the value of a, then I'll just get a is equal to 2 over 6 can be reduced down to 1/3. So we'll reduce that down. So a is going to be 1/3. Okay. Now I can do the same thing to find the value of b. So let's do that. So to find the value of b, let's let x equal -4. Because if we let x equal -4, then what happens is we plug in, we'll get -4 plus 4, which is 0. So that'll cause a to drop out. And then we'll need to substitute it in for this x over here and that x over there. So if we do that, and then what we'll end up with is basically -6b is going to be equal to -4. We can divide both sides by -6. Dividing two negatives, same thing as multiplying by two negatives. So I know I'm going to get a positive value. So it's going to be b is equal to 4 over 6, which can be reduced down to 2/3. So b is going to be equal to 2/3. So that is the value of a and b. Okay, so hopefully you're able to see that. Okay, now we just got to go back to the integral itself. So just for context, I pulled the 3 out earlier. This is the integral we had when I factored out the constant. And by using the process of taking the partial fraction, here's what we have now. Excuse me. Dx plus the integral 2 over 3, then it's going to be x minus 4, or excuse me, x plus 4, excuse me, and then dx. Okay, so this is where you should be after, actually, be appropriate to use parentheses. All right, so let's just go ahead and evaluate the integrals themselves. So what we'll have is 3, the integral 1/3 over x minus 2 dx. That's just going to be 1/3 ln absolute value x minus 2. Okay, and then this will be plus the integral 2/3 over x plus 4. That's going to be 2 over 3 ln absolute value x plus 4, and then plus c. And you can go ahead and distribute in that 3 and simplify things out, and we can write our final answer after we've done that. So we're asked to integrate 3x over x squared plus 2x minus 8 dx. So if we take the partial fraction here, I'm going to write my answer this way. I'm going to write my answer as 2 ln absolute value x plus 4 plus ln absolute value x minus 2 plus c. And if you want to use properties of logarithms, you don't have to, but let's say you want to use properties of logarithms, you can write your answer as ln absolute value x plus 4 raised to the second power multiplied by x minus 2 and then plus c. So if you want to use properties of logarithms, you can write your answer that way as well. All right, so that's going to be your answer. So let me circle that for you. All right, so if you guys got any questions about how I arrived at my solution for this particular integral, please let me know. I'll be more than happy to discuss it with you. But that's going to be it, and I will see you guys next time.